if a machine cheats, is it alive? In the 1970s, 4-year-olds were already wrestling with this question when they started playing with the very first electronic toys, toys like Simon and Merlin. And as they tried to decide whether the machine was alive or not, they ended up redefining what it means to be human. Imagine this kid named Robert, and this is someone that Sherry Turkle observed, and Robert's friend Craig showed him how to beat Merlin at tic-tac-toe. And there's a trick. Merlin, the toy, follows this optimal strategy most of the time. And if you know tic-tac-toe, you know you can always win, or at least you can always keep yourself from losing. It's pretty simple. But young kids don't know that yet, so they actually will lose because they don't know all the rules. Now, Merlin can win all the time, but that would be a pretty boring toy, and children would get really frustrated. So it sometimes will make a slip every now and then. Merlin is programmed to make mistakes every once in a while. So children discover a strategy that will sometimes allow them to win because Merlin makes a mistake at that point. But then when they try it the second time, it doesn't work because Merlin only makes mistakes randomly. So the machine gives this impression that it's not dumb enough to let its guard down twice, right? So you beat it one time and now it looks like now it's smart and it's not going to let it happen again. So Robert has watched his friend Craig perform this winning trick, he calls it, and now he wants to try it himself. So he plays his part perfectly, but this time Merlin plays a perfect game and it leads to a draw. If both players are playing a perfect game, then you always have a draw. So then Robert gets mad because Craig just beat it because that time it was making a stupid mistake on purpose. So Robert accuses it of being a cheating machine, he calls it. And then he says, if you cheat, you're alive. Now check that out. He says the toy cheated, and that means the toy is alive. He says if something can cheat, then it's alive. This is a machine that surprises as well. It does things you can't predict. So they go on and talk about this toy, Craig and Robert. And Craig says, Merlin doesn't know if it's cheating. It doesn't know if it's going to break. It doesn't even know if you break it. Robert, it's not alive. And then Greg is there too. And Greg says, someone taught Merlin how to play, but Merlin doesn't know if he's winning or losing. And now Robert is the one who's mad because he couldn't win. Robert says, yes, he knows if he loses. He makes different noises. Greg says, no, stupid. It's smart. It's smart enough to make the right kinds of noises, but it doesn't really know if it loses. And that's how you can cheat it. It doesn't know that you're cheating. And when it cheats, it doesn't even know it's cheating. So these kids are 4, 5, and 6, and they are thinking about what it means to be alive. Does the machine know what it's doing? Does it have intentions? Does it have consciousness? Does it have feelings? In the hands of children, these computer toys do something else. They don't just let you have fun, but they give you an opportunity to start making theories about what it means to be alive, thinking through, I guess you could call it metaphysical questions about what it means to be a person. And remember, these are 4, 5, and 6-year-olds, so they're still developing some ideas and concepts that might seem pretty straightforward for adults like us. So this is the sort of thing you think about when you're thinking about humans' relationship with computers. How do we interact with computers? We adults, we know that computers aren't alive. And if you interview me, I'm going to say, of course, the computer is not alive. But when we interact with computers, we often interact with them as if they're alive, right? They do something we weren't expecting, we get mad at them. We might swear at the computer. We are going to use second person. You'll say, you did this, you did that. You'll say, you made me angry. So people do interact with computational devices as if they're alive, even if you say that they aren't. So this is the sort of thing that an anthropologist like Sherry Turkle is interested in. And then when you're talking to children in particular, and this is in the 1970s when no one had seen these computational devices before. Now you've got something like Merlin and you've got something like Simon, the toy with the 4 buttons. It seems kind of like it's smart and it seems like it's talking back to you. And now Merlin, which makes mistakes some of the time on purpose, it seems like it has intentionality. So what happens is the children start projecting onto it beliefs and intentions, and they'll say, "Oh, Merlin made a mistake, and I beat it, but now it's figured it out and it's not going to let you beat it twice." So you really are talking about it as if it has intention as a human. So children are seeing things like this as if they're on the margins of being alive. Now I'm going through chapter 1 of Sherry Turkle's book from 1984, and it's called The Second Self. And she calls it The Second Self. It's a very clever name because she thinks the computer, not only that the computer is a second person, that's not what second self means. What second self means is that the computer reflects back at you and leads you to have a second conception of yourself. You see yourself differently when you have this new, apparently intelligent device and you're interacting with it. And now things you used to think were defining features of intelligence, this other device seems to have these abilities as well. But you feel deep down that it's not alive. So now it changes your conception of what it means to be alive. And that's how there's a reflection of a new conception of who you are. So remember, this book is from 1984, and so much of what's in it, I just went back and reread it. Here it is in 2026, and it feels like this book could have been read and written just last month, because we're still dealing with all the same things. We still have computers that reflect back at us and change the way we think about ourselves. So Turkle goes on in chapter 1, and she starts to talk about another child. It's Matthew, and he's 5 years old. He's precocious, a very smart kid, and he's learning, 5-year-old, he's learning to write computer programs to make graphic designs on the screen. He's using software that was new at that time. It's called Logo, and it was designed at MIT to be very easy to use for children. The idea was we're going to see what happens when we give children the ability to program the computer. We're going to give them this control. They can be creative. And with the Logo software, you can make commands like move forward, move right, move left. And as the cursor's moving around, it's actually drawing these patterns on the screen. So you can write a simple program that'll make a square or make a triangle. And you're 5 years old, you can do that. I mean, you have to be a pretty smart 5-year-old. Back then, they were really expensive, so you had to be, a pretty affluent 5-year-old as well. Now, technology like this seems very primitive. So here Matthew is, and he's trying to make graphic designs on the screen using Logo. He got really upset at one point in the middle of his programming. He was so upset that he was tearing up. And what happened was he figured out how to make a recursive program. And recursion is when the program calls itself, and then it calls itself again, and then it gets nested loops over and over. And when you make a recursive program in a way that there's no instruction for it to stop, then it just keeps going and going and going because the program's always calling itself over and over. So imagine that you draw a square and then you change the length of the side a tiny bit. Then you say draw another square. So now you've got a smaller square inside the bigger square. And then you tell it to make the side a little bit smaller, and then you draw another square. So if you have that kind of loop, you're going to have a bunch of concentric squares all the way going down, and then you get to the center, and then there's a little dot, but it's still going. So here's Matthew, this 5-year-old, and he kind of accidentally figured out this notion of recursion, and it freaked him out because it was so strange and powerful. The program does this action which sets off the same action in another program indefinitely. So once the program starts, it goes on forever. Now, Matthew was kind of afraid at this point because this is a real power, that the computer has. His experience was complex. It was confusing. This happens a lot when children first discover this notion of recursion. I mean, you imagine there could just be a children's picture book where on the cover there's a girl, and the girl is reading a book, and on the cover of the book she's reading there's a girl, and that girl is reading a book. And So you don't need a computer to have this happen. And Sherry Turkle, as she's writing the book, she says when she was a little girl and she saw this book cover, she was kind of freaking out and she was afraid. So you see this with computers as well. And I don't know, imagine a child just freaking out because of this capability that he had stumbled on. So here it is, the power of a computer to do something that you thought was uniquely human, or in this case, something that you didn't even know how to do yourself. It seems like a magic spell. It seems like it has this magical power. This is a 5-year-old. Now, maybe this is you as well, the 25-year-old or 40-year-old, and we're playing with ChatGPT. It doesn't seem like it has magical power. Maybe. Now, researchers going back a long time have realized when you study very young children that they see almost everything as being alive. I mean, the trees, the clouds, that's kind of their default assumption about the world. They call it animism. And animism pervades a child's thinking until later when you have the development of concepts that helps them draw the line between things that are alive and things that are not alive. So this is an ongoing developmental process for children. It's been happening since long before there were computers in children's intellectual development. And you're developing concepts about what it means to be a person, what it means to be alive, what it means to be human. So it makes sense that children would be disturbed when this boundary between the living and the not living is changing suddenly in ways that are not developmentally appropriate for them. When a computer behaves as if it's halfway between a person and a thing. So think about that, and think about that in the 1970s when you have this new toy called Merlin where you can play tic-tac-toe, or you have Simon, or in this case of Matthew, you have very simple computer software that allows you to program a computer. So now Sherry Turkle goes back and is talking to a girl named Laura, and Laura is playing with Merlin, and she realizes that Merlin has this tic-tac-toe mind, she calls it, and that his tic-tac-toe mind is just really good at playing tic-tac-toe. So she says to herself, how does he win so much? He's trying to make me lose, right? So that's what I meant when I said you interact with the computer as if it's alive. But for a child where they're still developing an understanding of the separation between living and not living, that's a really fuzzy boundary. So here Laura is just getting completely absorbed. She doesn't even look up. She kind of forgets that Sherry Turkle is even there. Watching her, Turkle is doing research, so she has a tape recorder. So Sherry asks her, do you think Merlin could lose if it makes a mistake? And Laura's not really sure. She says, yeah, I'm not really sure. So she's so disturbed that she begins to turn off Merlin in between games. And it becomes kind of a ritual. She doesn't want to leave it on in between games. It's kind of weird, like she doesn't want it sitting there still being alive. She thinks her power over the toy is that she can turn it on and off. So she turns it off and then she turns it back on and plays another game. But Merlin still wins. So she turns it off. She plays another game. Merlin wins again. After 5 minutes of this frustration, she just puts it aside. And now she picks up another toy called the Speak Spell. And the Speak Spell is another toy that fascinating for children interacting with. And Sherry Turkle's been observing this as well. So Speak Spell in the 1970s, it was a toy that can talk. And it's got a keyboard and you can type on it. So Laura spells out her name, Laura. And then Laura puts Speak Spell into this mode called the Say It mode. So Speak Spell has this button that turns it on and has another button that turns it off. It has buttons that choose among different possible play modes. And in the spell mode, the toy calls out a word and then the child has to spell it out by pressing the letters on the keyboard. And if the child makes a guess, and if the child gets it right, the game says, congratulations, or the game gives you a second chance. Then there's a mode called Hangman, where the toy offers blank spaces and clue letters on the screen. and invites the child to complete the secret word. And then there's the say it mode. That's designed for really young children, and like Laura, who might not be able to spell much more than their names. So the machine calls out the phrase say it and then follows it by one of the words. It's got a vocabulary of several hundred words. So it might do something like say it happy, say it lose, say it house. And the child gets a chance to repeat the word. Pretty straightforward. So Speak and Spell, it's designed that you can turn it on and off, just like any of these electronic toys. You can turn it off in the middle of the hangman game without completing the spelling of the word. But the Speak and Spell, when it was first released, it had this really interesting bug, this programming mistake, that you could not turn it off when it was in the say it mode. In the say it mode, there are 10 words, 10 say it commands, and you just could not turn it off until it finished saying all 10 words. And you couldn't change the mode either. You couldn't turn it off. So it's going to keep talking. You're pushing the off button. So it's not checking to see if the user is pressing the off button. That was the computer bug. It was kind of trivial, but it was discovered too late. So the company, they'd already made a lot of these games. The company said, you know what, we're going to sell them anyway. Doesn't seem like a very serious problem. But it turns out it's a great topic for research because it's really freaky to 4-year-old and 5-year-old children. So the say it cycle, the thing is saying 10 words. It takes a long time. So when children first start playing Speak and Spell, they try to turn it off when it's in this say it mode, and they discover they can't turn it off. So it's like science fiction, right? Where you can't turn off the computer, it's taking over. So for the child, it seems like Speak and Spell has developed a mind of its own. Now, this is the sort of thing that happens when we're interacting with computers. And remember, this is in the 1970s, and it's a very simple toy, and it's a very young child. But this is our situation today with all of us. I mean, now we've advanced all the way up to artificial intelligence, and we have the same questions. What does it mean to be alive, and what does it mean to be not alive? It seems like an intelligent being certainly is alive, and it used to be that human beings were the only intelligent beings, so we could make that be the divide between alive and not alive. Things are alive if they're intelligent. You can say, okay, what about your dog or your cat? Oh, it's not intelligent like a person, but, it seems, it's not dumb either. I mean, it does smart things. When it's hungry, it goes to the food bowl. If you throw a ball, the dog runs, picks up the ball. So, yes, alive things are intelligent. And then you say, well, what about trees? Are trees alive? So when children are developing, they actually evolve their understanding of what it means to be alive. But then now we're talking about adults, us, and artificial intelligence, and we're talking about human level intelligence. So does it mean now that anything that has human level of intelligence is alive? That used to be our divide, right, between alive and not alive. A lot of the discussion today about Gen AI is about things like consciousness and artificial general intelligence. Is a generative AI as smart as a person? And not only that, but does it have consciousness? Does it know about itself? Does it think about itself? Does it have emotions? Even in the 1970s, there were already philosophers looking at computers and talking about whether or not they were alive. What was their status as intelligent beings? This was at the core of early days of artificial intelligence, and it still is the core of AI today. But I mean, even back in the 1950s, when the term artificial intelligence was coined, people were thinking about these very old primitive computers and asking questions like, what does it mean to be human? What is the difference between a smart machine and a human being? It was back in the 1950s that Alan Turing developed his famous Turing test for intelligence. And he said, how do we know that a machine is intelligent? We could say if its mind works just like a person's mind, then it's going to be intelligent like a person. But then we have to look inside its mind, and that's going to be really challenging. So Turing came up with his Turing test, which was focused purely on behavior. Basically, if the computer behaves so much like a person that you can't tell if it's a person or a computer, if they're indistinguishable to you, and it's a behavioral definition. So Turing said that's the Turing test. The computer has passed the Turing test. And, he said you can't expect the computer to have a body and sit there across from you and have dinner and drink wine. That was not the definition of being a human in his case. It was behaving intelligently. Now, is that being alive? In the case of the Turing test, that wasn't the issue. But with Sherry Turkle, she's focusing on these children. And at the 1970s, the same time that this was going on, you might have heard about Joseph Weizenbaum's program called ELIZA, ELIZA. And ELIZA was this very simple program that would basically parrot back to you whatever question or whatever thing you said. But it was designed to do it kind of like a psychotherapist, where you would say something like, I'm having trouble with my girlfriend. And then Eliza would say, I hear you saying that you're having trouble with your girlfriend. So it basically would just put whatever you said and then put some other thing in front of it, like, tell me more about you're having trouble with your girlfriend. So people, turns out they really, really got a lot out of talking to Eliza. They could tell it was not the same as a person. So they knew that, but it didn't matter. They still were having a very satisfying encounter. Now this again, maybe this happens to you with Gen AI as well. You're like, yeah, it said some stuff that a person wouldn't say, but I'm going to let that slide because I'm having a very positive encounter with this device. So with Eliza, for example, people got so involved with it, but they also knew it's not alive in exactly the same way. So they would cut it some slack, and they would actually, be nice to it. They would only ask questions that they knew it would be able to answer in a sensible way. So the user of Eliza was collaborating with Eliza in the illusion that we're having a real therapeutic encounter. And really they're helping themselves by helping to maintain the illusion of having this kind of interaction. I mean, Eliza was a really dumb program, but people were able to make it work to satisfy them. And, Gen AI is so much more advanced that that's fairly easy to do. It doesn't take a lot of work, but, it's going to do things wrong. It's going to hallucinate. If you get good at interacting with Gen AI, you learn how to work with it in these ways. And like I said, you kind of cut it some slack. So again, back to Sherry Turkle, and I'm still just in chapter 1 of her book, is her study of, she actually studied 200 children from a very young preschool age all the way up to 11. And all of that research she put together in just chapter 1 of her book. And later chapters I'll be talking about later. She's got a chapter where she went and interviewed artificial intelligence developers. That's a whole chapter. So I can't wait to talk about that chapter. So she talks about another child named Lucy. And Lucy's a little bit overweight, and she's not popular, and she's quiet. So the other kids sometimes pick on her. They're bossing her around. And she gets used to playing Speak and Spell, and now she feels like she can boss around Speak and Spell. She has someone to bully, I guess you could say. So she wants to give Speak and Spell an awareness of who she is. She actually wants Speak and Spell to have a consciousness and a psychology. She wants it to be a little bit alive so she can have this relationship with it, but where she is the one who's in charge, right? That makes it a much more powerful experience in terms of making her feel good about her agency and her power. She wants to have a sense of control over the object, but having a sense of control over a colored block, you're building a block tower, right? You're 4 or 5 years old. Yes, you control the blocks. And that's nice, I guess, if you're 4 years old. But if you can be in control of something that seems smart, then that's much more affirming for you, right? Uh, it's a much more advanced and fulfilling type of power relationship than, I've got control over these blocks. Now you've got control over, remember, it's the animistic world. You've got control over something that seems like it's alive. Objects can have the power of active agents, and sometimes they can have sinister intentions. Uh, Laura actually got afraid when she could not turn off the speak and spell because it has to finish its 10 words. You're like, it has its own desires and it's not doing what I want it to. I mean, again, remember this is 4 and 5 year olds at a time when computer toys were just being invented, so they hadn't seen anything like this before. So what is really happening is that they're dealing with the border between what's alive and what's not alive, and they have to use a kind of developmental understanding, a kind of logic to redefine these boundaries. So they need to recreate a stability in the world so that, once again, I could say, yeah, this stuff is alive, this stuff is not alive. What's disturbing is when the boundary is fuzzy, when we're not really sure. That kind of thing, that uncertainty leads to anxiety. So the nature of child development is that when you encounter uncertainty, you try to, as Sherry Turkle says it, you try to develop a metaphysical theory that is coherent and that helps you understand the world. So you can get a lot of mileage out of just studying what children do with their computers, or computer toys in this case. It'd be great to redo this study today. I don't know if you saw children interacting with Gen AI. I think they would probably just agree right away that it's alive. I mean, they can't. Gen AI doesn't have the kind of flaws that we see with Merlin. All it can do is play tic-tac-toe. But already in the 1970s, children were being confronted with highly interactive objects. Now they're talking, they're teaching, they're playing with them, and they're actually winning games with them. So children really aren't sure if it's alive or it's not alive. But they know that the definition of what's alive has to change. For example, you don't have to be able to move to be alive. Where a child, 100 years ago, it's not alive unless it's moving around. So, other animals. So it's not about being physical or mechanical in some way. It's now about psychology. Now that's what's changed in the 1970s. That's what's changed with computers. When you're thinking about what's alive and what's not alive, you're thinking about these deep metaphysical questions. Now you're thinking about psychology. You're thinking about what's inside the head, as it were. That wasn't happening 50 years ago. Is a tree alive or is a tree not alive? You didn't have to think about the psychology of the tree. But now your definition of alive, it's about psychology. So you have to develop a theory of cognition. You have to develop a theory of what thinking is and what feeling is. And these 4 and 5 year olds, they didn't have to think about this, again, 50 or 100 years ago. So that's why Turkle calls it the second self, right? It's reflecting back to us because you're 5 years old. You're not thinking about your own head. You're not thinking about your own psychology. That's not what 5-year-olds do. But now that you're confronted with this machine that seems to have some capabilities of thinking and intelligence, and you're asked, is this thing alive or not? You have to think about yourself in a new kind of way. You have to think about yourself as a cognitive being, and what kind of cognition is it that distinguishes me from this toy of Merlin. So, you and I can say, well, that's going to be pretty easy. All this thing can do is play tic-tac-toe, and it loses some of the time. But remember, these are young kids who hadn't seen this before, and we still are facing the same thing at a much more sophisticated level. So anyone who's concerned with or thinks about what's the difference between Gen AI and me, you have to start thinking about what's going on in your head. Uh, what are you thinking as you're solving problems? What are you thinking as you're faced with the world every day? How is the way you think different from how Gen AI might be thinking? Every one of us who uses Gen AI is going to be thinking these ways, even if, not consciously. But it is a kind of metaphysics, it's a kind of epistemology to think about, how do I understand the world? How do I think about the world? And how is that different from what's going on with this web platform I'm using that seems to be very intelligent? What's going on is that all of us are becoming metaphysicians, I guess you could say. All of us are becoming cognitive psychologists. All of us are becoming philosophers of mind. And we all develop these theories of what it means. What does it mean to be human, and what does it mean to be alive? Stay tuned for the next episodes where I talk about the rest of the chapters in Sherry Turkle's book, which is called The Second Self. What Sherry Turkle saw in the 1970s, we're still experiencing today. When machines begin to think, we don't just redefine them, we redefine ourselves as well. The real question isn't whether computers are alive, it's what our answer says about us. If you're interested in how creativity, technology, and human identity intersect, then subscribe, and I'll be continuing this series on the second self in the coming episodes.